So I'm very happy today to be hosting Dr. Alexandros Karakostis to discuss his recent PLOS ONE Lab Protocol paper entitled Introducing Validated Entheses-Based Reconstruction of Activity 2.0 or VERA 2.0, semi-automated 3D analysis of bone surface changes, and the associated detailed protocol in protocols.io. Alexandros is a permanent senior researcher and group leader affiliated with the University of Tübingen, the Senckenberg Research Institute, and the University of Basel. His work mainly focuses on leading multidisciplinary projects aimed at reconstructing human habitual behavior in the past through virtual analysis of their skeletal remains. This is combined with laboratory experiments used to empirically validate his methods. Alexandros has developed and experimentally validated new methods for activity reconstruction, including VERA 1.0 method, validated entheses-based reconstruction of activity, first developed in 2016 and since then widely applied across both early and recent hominin contexts. Additionally, Alexandros currently leads the research group Co-Evolution of Tool Use and Language, where his team conducts neuroarchaeological experiments to investigate the cognitive and biomechanical implications of early hominin stone tool use. Alexandros, thank you so much for coming here to discuss your protocol and paper.
Thank you very much for having me. It's great to be here. Yeah.
So to kick off, can you briefly explain what this protocol is about, how to use it, and why it is relevant?
Of course, like you mentioned before, this paper essentially and the associated protocol introduced the VERA 2.0 method, also called the validated entheses-based reconstruction of activity. That is the new version of VERA 1, previously developed in 2016. So VERA 2 is a new, fast, and easy to learn tool for reconstructing habitual physical activity performed in the past, based on the morphological analysis of dry bone remains, such as those we find in the field or that are curated in museums. And these can belong to our ancestors, can belong to humans, but can also belong to other animals. It does that specifically by focusing on the areas of the bones where the muscles or ligaments used to attach in life. And the plan is, well, the aim is to infer habitual use of these muscles in order to help us reconstruct activity.
So to further understand the significance of the protocol, both for VERA 1 and VERA 2, can you tell us a little bit more about what was the state of the art when you decided to develop these methods? What other methodologies existed in the field that would allow what you wanted to do but didn't work for you for some reason?
Exactly. This is there are several important reasons why I first embarked on this journey of trying to find new virtual methods to analyze muscle attachment sites on bones or entheses. And this is primarily because even though other methods, of course, exist and they're very valuable, they cannot provide all the important information that VERA 1 and now VERA 2, perhaps even more, can provide. For example, when it comes to other methods focusing on entheses, on areas of attachment, even though there are many observational methods that do not rely on virtual analysis and quantitative data, these have never been experimentally validated in the lab. They are used directly to infer activity, but they were never tested. And this is one of the things that I have been working hard on with VERA 1 and now with VERA 2. Another limitation of other methods, not just on entheses, but in general, is measuring repeatability, something that I especially worked hard on with VERA 2. The idea is to provide a protocol and a technique that can be learned fast and accurately and can be replicated. And it is often the case that not every technique is as easily replicable or repeatable. And this is also something that I have worked hard on. There are other important advantages of the VERA protocols. For example, other methods in activity reconstruction, as we call it, provide important insights. For example, they can tell you if a bone is more robust in a cross-section in different parts. They can find differences between people, the skeletons of people performing different things. However, they often have the problem that they cannot pinpoint specific movements because a bone can be thicker here or there for different reasons. So unless we manage to link what we see in bone with muscles and their function, it's difficult to provide more refined understandings of what kind of movements and activities were performed. And this is where VERA comes in. It provides a repeatable virtual tool to reconstruct muscle use and therefore provide a better understanding of activities in the past, also backed by laboratory evidence that together with colleagues, I have worked hard on providing. And VERA 2 is the next step in this. Yeah.
So I won't pretend to be an expert. It is my understanding from what you described in the paper that the main difference between VERA 2 and VERA 1 is that VERA 2 incorporates a semi-automated image segmentation technique. Are there any other improvements in VERA 2 in relationship with VERA 1? And second question, how this semi-automation improves the method?
That's a great question. So ever since VERA 1 was first introduced in a paper in 2016, even though the name VERA was given years later in a literature review in 2021, since 2016 it has been applied quite a lot. So this was quite exciting, both in my research and others applied the method and found very interesting things, very interesting facts or insights into human evolution or even recent understandings of behavior. Nevertheless, throughout all these years, and while I was training people, researchers, both in person or online from many institutions worldwide, while I was training them in VERA 1.0, I noticed there were several disadvantages. One was that it required substantial time for training someone. You see that the VERA 1 process is quite rigorous. It involves examining this area where muscles or ligaments attach from different perspectives, spending some time and getting to know how exactly you can use the various virtual tools to define the borders of this area. And of course, this is also time consuming when analyzing materials. So first of all, I had in mind that the more a field, like every field, moves towards automation and making things easier, more accessible, fast to learn and apply, another step was needed, and semi-automation provided this step. However, on top of the practical advantages of VERA 2.0, there is an additional essential conceptual advantage that has to do with the exact focus of VERA 2.0 compared to the first one, to its predecessor. You see, VERA 1 essentially focuses on measuring, on distinguishing the entire bone structures, like the entire tubercle, for example, or a projection where the muscles attach. It doesn't focus on the exact footprint of the tendon. It doesn't find direct, subtle deformations, irregularities on the bone related directly with muscle or ligament pull. It's fine because also by looking at the entire structure, you can get important information as we showed in the past. But VERA 2 is able to capture this subtle, very, very non-distinctive in the naked eye, even on a 3D model that is virtual, these subtle deformations related with this stress experienced by the bone when muscles or ligaments pull. And in previous research, also in laboratory mice, I did see that these deformations were more representative of how much a muscle was used. I also included in the PLOS paper an anatomical dissection. So I also tried a cadaveric analysis on a thumb, and also found, at least in this pilot study, in that pilot anatomical study, I found that the changes of the surface automatically identified by VERA2 did correspond indeed to the footprint of the tendon and where the soft tissue was attaching, which was quite promising and encourages further research in this direction.
I would like us now to elaborate on this exactly. I mean, you
Mm-hmm.
already mentioned, but can you tell us more about what kind of experiments or analyses will VERA2 will enable or has enabled that weren't possible before with other techniques or even with VERA1?
That's a very that's the key question, right? How this can help us? I think that first of all, like VERA1 did before, VERA2 could also be applied on on various key important contexts, including fossil hominins, for example, or even recent archaeological contexts, because it could build on VERA1 and it could expand and provide an even finer understanding of what kind of activities were conducted, for example, by Neanderthals versus modern humans, and answer questions on key aspects of biocultural evolution and behavior, like bipedalism in the past, for instance, or even, of course, address more recent contexts, how different people of different socioeconomic status, what kind of different activities they performed in the framework of different cultural contexts, which is extremely exciting. However, something else that VERA2 can help us with is, especially when it comes to trying to figure out where muscles or ligaments used to be, especially in extinct fossil species, where muscles and tendons, of course, are not preserved. And also, we have no idea where exactly they were. We assume that based on general anatomical comparisons, but we're not sure about the exact area where they attached. And assuming that we keep building on the evidence found in this anatomical part of the paper, and that, as it seems, we further prove that VERA2 can help us identify the exact locations of muscle and ligament footprints, that could lead to a revolutionary step in evolutionary sciences, because we could educate our musculoskeletal models to know with exact locations of the soft tissues and get a much more accurate understanding of how different parts moved. For example, how Australopithecus sediba was using the thumb based on bone morphology and the location of the soft tissue. So, of course, it needs more research, but I do think it has exciting possibilities. Finally, related to that, I think that, and I also mentioned that in the paper, I believe that VERA2 should also be seen even outside entheses. It should be seen as a tool for analyzing very subtle, discrete changes in surface morphology. And maybe one could consider taking this and trying it on other surfaces that are interesting, like on maybe stone tools from the past, or even trauma and injuries on bone. Perhaps this has to be tested, but perhaps it could develop into a broader tool for analyzing discrete morphological changes. So that would be another line of potential future research.
Very interesting. I would like us now to go a little bit on the optimization per se of the protocol, on the work that you did to get this paper published. And I don't know if you can tell us about what were the highs and lows during the optimization. And more importantly, as you were semi-automating VERA1 to make VERA2, was there anything that you tried that didn't work and didn't make it to the final version of the protocol?
Developing this protocol involved extensive work and a great deal of trial and error, and this ultimately resulted in this detailed step-by-step instructions and algorithm script. Fortunately, every effort contributed more or less to something within the final outcome, even if that ended up being a smaller detail. So I wouldn't say that there was an attempt that led to nothing. However, something that was quite demanding had to do with the steps required before running the automatic algorithm, and something, for example, developing exact regions that the user has to select, which is the only manual thing that the user has to perform before running the algorithm. This required a lot of thinking, how to define anatomically the exact areas, what to leave in, what to leave out, and how to make this coherent and clear for future users. So this defining this, as I call it in the paper, BSR, broad selection region, was demanding, and also to find ways to make it possible that people can apply this protocol on bones on 3D models of different resolutions. You see that depending on the scanner you use and the parameters, you have different resolutions, and this can affect what you measure, and especially when you're focusing on something so subtle. So this finally worked, but it required a lot of trial and error and thinking of what kind of parameters, what kind of steps could be used and could be incorporated to allow for a proper use of the method in the future. But finally, based on all the trials, it seems it works. So I'm really happy about that. But this was a challenging step.
So at the beginning of our conversation, you mentioned that Vera 1 required a lot of time-consuming training. For those that are listening and watching to this video, what is your advice in terms of the application of the technique, of the method? What are the most critical steps? You already mentioned the manual selection of the broad bone region. Is there anything else the user must be aware that is tricky and that they might make a mistake on?
Absolutely, this is a good question. And yeah, in contrast to Vera 1, first of all, I would like to say that Vera 2 is much easier and fast to learn. Essentially, if one follows the steps provided, and especially the first time that they try, they have to follow them exactly like provided. Then it should be quite easy to learn, even without asking further questions or personalized training. However, I do encourage very, very emphatically anybody to contact me directly if they have questions, and I'm very happy to support it. What is challenging, I would like to emphasize again, is essentially the only manual step, which is to select this broader region. You see, in the protocol, I provide 9 detailed steps for 9 examples of entheses across the body that are important. And there are many others that look like them, very similar in where they are, or anatomically or morphologically. So, but there are also others that are not very similar. And of course, protocol cannot include every muscle attachment in the body. There are a lot. So what I recommend inside is for future researchers to try and develop their own broader selection regions, following the logic provided and asking for support at any time. And this will lead to the continuous growth of the method. So this is one step. If somebody wants to run analysis on an entheses not covered in the protocol, or not even similar to those covered, they will have to put in some thinking about the selection region. But I think that if somebody studies the protocol carefully and understand the criteria of the selection region, this is something that is very feasible. Another step, again, is the resolution. It's important, and I have even bolded these requirements in the text in the protocols paper. I have emphasized specific steps required to make sure that the mesh structure and resolution is consistent in the sample. So these are the main things. And of course, as any listener or any viewer that works on entheses will know, another question is always pathology. How do you deal with pathological lesions and changes? And of course, extensive information on how to deal with such pathological lesions or even taphonomic damage is provided within the paper and the protocol. And this is something that one should also consider in the beginning of the study. They should consider, first of all, if they would like to remove them or keep them in the analysis, and what would that implicate.
And I would like us to change gears now a little bit and talk about the motivations for sending the method to PLOS ONE to be peer reviewed as a standalone methodological paper.
I actually saw the combination of having a detailed validation and an introductory paper in PLOS ONE alongside a clear step-by-step structured protocol at protocol.io as an ideal format presenting this work. I was a co-author in previous papers and protocols published in this combination, and I did appreciate how it's possible to combine these two, link them directly, and allow for researchers and readers to both understand in detail how something works and how to replicate it, and at the same time read about its validation and its discussion separately, but at the same time in a connected framework. Also, PLOS ONE is an interdisciplinary journal that has a good reach to research from different fields. And a lot of researchers in ecological sciences also publish there, and they read a lot of papers published there. There's a wide methodological literature as well in ecological sciences published in PLOS ONE. So I thought it was an ideal venue for presenting this new protocol.
And how did the feedback that you received from the peer reviewers help you improve the final version of the protocol?
The reviewers helped me, the PLOS ONE reviewers, helped me to better clarify the goals and the significance of this protocol, especially within the context of archaeological sciences. They also highlighted the value and future potential of the section of this protocol that focuses on the anatomical dissection analysis I mentioned earlier. And this feedback made me further appreciate that such anatomical analysis of soft tissue and its interaction with bone represent an entirely new line of research enabled by VERA 2, which is needed to be addressed in the future so that we can get an overall better understanding of how bones and soft tissues interact on the basis of this new approach and other tools. So maybe such analysis, and this is something that I could realize and understand more, thanks also to the reviewers, could help us understand exactly how also, not just the what and when, but also the how of the soft tissue bone interactions occur. If that makes sense.
Yeah.
Yeah.
And my last question might be a little speculative at this point because the paper is really young. I think it was published about 3 weeks ago or so,
Yeah.
2 or 3 weeks ago. But we know already that VERA 1 has been quite successful and widely adopted. So based on that, what do you think will be the significance of publishing this methodological paper for your career?
That's a good question. Indeed, VERA 1, since 2000, for the last 10 years almost, VERA 1 proved to be an important tool, and that of course benefited a lot my own projects and activities and career. VERA 2, my opinion, will hopefully have a similarly good development. I really strongly believe in the capacity of this method to provide even finer understandings with less of physical activity in the past, and behavior and critical aspects of biocultural evolution while requiring less effort. So I do believe that VERA is a significant step forward, and I do believe and hope that it will be adopted by many researchers, hopefully, and that therefore it can further expand, first of all, research directions in general, not just mine, but also perhaps provide more opportunities for my team and myself, hopefully, to work on other exciting materials and address other exciting questions.
Alexandros, I don't have any other question to add at this point. I don't know if you would like to mention anything that hasn't been discussed so far.
No, I think actually that was quite clear. Of course, there are always details and questions, and I would just like to emphasize again that I'm always happy to answer questions or discuss about the approach itself, and I'm always reachable to anybody interested in learning more. That's all.
Thank you so much.
Thank you.